Wonder what you'd do if you could control an OpenSim scene externally? Well, our speaker, Dr. Crista Lopes, is here to give us some ideas. AKA Diva Canto in the world, she's a professor within the Department of Informatics, Computer Sciences at the University of California, Irvine. She's a core OpenSimulator developer who developed the hypergrid. In 2016, Crista was the first woman to be awarded the $10,000 Pizzagatti Prize that honors software developers who are working to develop open source applications that aid activists and nonprofits involved in struggles for social change. I want to welcome Dr. Lopes, and I will pass her the mic.
Creating content in this virtual environment. So what we inherited here in OpenSimulator was this really amazing authoring platform for creating content live, shared with multiple people. And usually what you do, you've all done this. You just create a prim, you right-click, edit the prim, change some parameters, add textures, and it's just really, really, really simple. And this is probably one of the best things about these environments is how easy it is to create 3D content. I mean, there's nothing, really nothing compares to how easy this is. And this is great. So what happens when you create these primitives is that so I'm going to go talk a little bit technical here, is that you create these objects with the viewer, and then on the back end at the server, the simulator creates an object or more that represents that object that you have created in world, and then that object is stored on the database. There's basically two main components to it. There's an asset associated, or one or more assets associated with that object, and then there's a primitive object that represents the object that we actually see on the screen. So that's how it goes. So it's a one-way situation. In one way saying that the viewer acts as the authoring tool, right? So we are using the viewer as an authoring tool. We create the objects using the viewer, and then those objects go to the back end and live there for other people to see when they join. There is a somewhat of a converse direction via scripting, right? Because one of the good things is that there's also scripting. You can script these objects. And so if you have an object to which you add a script, there's facilities in LSL that allow you to create other objects programmatically. So you can res new objects programmatically from the script, which is, again, it's deviates now from the model of the one-way authoring from the viewer. Now you have given the power for the object itself to author other objects and to add more content to the scene, and that is great. Now, but this actually kind of starts to break when in situations such as the one that I am most familiar with, which is one of my main applications of OpenSimulator, which is these very, very large scenes, urban level, city level scenes of kilometers wide, and not just the buildings are there, but also there's a lot of dynamic temporary content, like cars, for example. We have a traffic simulation. We have the potential to do other kinds of visualizations that are temporary in nature. So, things like pollution, for example. So there'll be these prims that represent certain amounts of pollution, but they just go away. And the characteristics of these objects depend on external data. So when you start looking at these kinds of very large spaces with a lot of content, and a lot of it that's not permanent by design. It's content that is dynamic, that depends many times on external data that changes, maybe even live data that you get it from some sort of a live stream directly from some server somewhere. So when you get into the situations, that's when the Second Life authoring model really starts to break. You can't really do it very efficiently with facilities that are provided by the Second Life model. I mean, you could do it a little bit with scripting. There's some capabilities of communication between the scripts and the external servers, but it's just not very fast, and it's not very good. And especially in OpenSimulator, as you all know, the scripting engine is really not what you really want to depend on. It doesn't work very well. So this is where things start to break. So what Mic did is really kind of a different model of looking into OpenSimulator and then looking into these environments and moving from authoring to complete application development. And there was a similar shift on the web in the very early days, when the web was just a place to put static documents that then other people could retrieve. And at some point, people started realizing, wait, at the end of a URL, what I can really have is a script. And that script now generates things programmatically, dynamically. And that's where things on the web moved from just simple authoring to application development, and you have now very complicated applications on the web. So that's the same thing here. It's the idea that now we can move from just the idea of authoring prim by prim manually by a person versus doing an external application development that injects objects into the scene, controls the objects in the scene for other people to see. And this control is done programmatically and externally by a script. That's the idea. So in this slide here, you have this orange application bubble on the right. That's really a script that lives elsewhere, and that commands what is going on in the scene, what kinds of objects are there, how they move, how they look, etc. So that's the idea. The code itself sits on GitHub, so it's called it's basically two modules. It's the remote control module and the dispatcher. And as I said, originally it was developed by Mic Bowman, and I forked it and I started making some changes. Some of my changes I put them back, and I haven't had the time to actually make a pull request of my latest changes. But there's a lot more that can be done. So Mic did the basics, which is really quite amazing what he did. And then there's more things that can be added that I have been adding as I need them for etc. So let me go a little bit deeper and explain to you how this actually works. So the way that this works is there's two parts to it. There's a part that works in OpenSim. So these are two region modules that can be installed as plugins on the simulators. They are called the remote control and the dispatcher. And what these are very generic interfaces for both controlling the objects on the scene and for sending events out back. So if certain events happen to the objects, for example, somebody moves them or touches them, it is possible for these external applications to get notified that that happened so that they can react appropriately. So that's the part that lives in OpenSimulator. And then externally, there's the remote control script itself. That at this point there's a binding for Python and another one for Perl, but it can be more, because basically what Mic did is to provide the REST API, a very generic REST API, and also some very generic UDP or TCP transport layer for going bidirectional. And that allows you to have this bidirectional communication between the server that controls what's in the scene and this external script. So what you can do in two directions, I have these three bullets there. Let me start with the last bullet, which is the third one: bypass the script engine. This is really important. So this does not use the script engine at all, other than, if some of the objects happens to have a script inside, then fine, it uses, it runs that script, but it's not necessary. And so that's a good thing about this. Now, from the script, the external script to OpenSimulator, you have capabilities of creating, deleting, moving the objects, changing the properties, colors, and things like that. And again, this is one of the things that Mick did the basics. I added some more things, and much more things could be added. In fact, one of the things that I added was the possibility to do this. So creation, deletion, and moving, and not just individual objects one by one, but a list of objects. So many objects at the same time. You externally say, here's a list of objects that they all should, should move according to these specifications. So that makes it much better performant. And you can do chat too. And again, this is open-ended. This is Mick did the basics. I added some more, and we can definitely add more capabilities in here. And then back from the OpenSim, the other direction, OpenSim to the script. Then, as I said, there's the ability of capturing the event. So the events right now, it's touch and move, because I needed the move event too. So if somebody changes something in one of these objects that are being tracked, then the remote script is notified and can react appropriately. So let me explain how I have been using this and why. So one of the things that I do in Incitra, as I said, is traffic simulations. And one of the really difficult and time-consuming things about traffic simulations is not so much the simulation itself, but it's specifying the traffic model. So basically the roads, the intersections, the directions of the roads, the speed limits and all of that. So it can get very complicated very quickly if you start thinking about how to define a traffic simulation. So for the longest time, people are complaining that they are losing the sound. I hope everything can still hear me. Okay, good. So for the longest time, the way that we have been doing this, defining these traffic models, is in world. We would go in world and put some waypoints and put some, metadata on the waypoints, like the speed and things like that. And this worked okay, but it was really time consuming. It just doesn't work very well. It's not the right way to do it. In fact, the right way to do it, I think many people already have it, which is this really good model that's called the OpenStreetMap model, which is used widely by OpenStreetMap and many, many tools that are compatible with it. They have a whole ecosystem of tools around OpenStreetMap, including several editors for traffic models. And one of them is JOSM, the Java-based editor for defining traffic models. And JOSM already does everything that we could possibly want and more. It's really, really good. So one of the things that we wanted to do was to create these traffic models with JOSM. So an external is a 2D editor, right? It's just 2D. It's like a regular 2D. I'll have a picture next. And we wanted to create these traffic models in JOSM, click a button, show the waypoints in world, and then also have the other way around, which is if some waypoints actually are slightly in the wrong position, and many times they are because you can't see everything just in 2D, then in world we do tweaks, we adjust the waypoints, and then this is bidirectional. This should be reflected back into the 2D model that you see in the tool in JOSM. So here's an example. Here's a picture of JOSM, and I don't know if you zoom in, you can actually see the some of the roads in red and blue. This is how JOSM looks like, and you define these layers. You can have many layers, you can have many types of nodes. It's really great. So you do this, and then at some point you can say export or upload to the server, and usually the server is the central OpenStreetMap server, and because this is meant to define traffic models in the real world. Luckily, when they developed this tool, this editor, they made the URL of the server configurable. So you can redirect this data to another server. And so that's what I did. We redirect this data now to our own OpenStreetMap server that receives the data here from the tool. And then from then on, once our server gets the data, then we can use this, as I said, this remote control facility to immediately inject these waypoints and make them appear in world. And this is an example of some waypoints that just playing around. And so, as I said, this is not just one direction. This is bidirectional. Then I can go here and move one of these waypoints if they're in the wrong position, and that is reflected back to the OpenStreetMap server. And in turn, the tool can then download the modified version of the traffic model, so that the person doing the model can get the data. So it's bidirectional. The model here is that you have several tools that all work over shared data, the same data, and they can both see different representations of the data. They can act on the data. They can change the data in different ways, and everything else. But everything continues sort of synchronized. It's everything. And what we really are doing here is using OpenSimulator and the viewer as a very rich 3D visualizer, basically. Right? So most of the application itself and the brains of the application is these external scripts, and OpenSim is great for visualizing these applications that we are constructing with probably with one or more external tools. So that's the idea. So just to finalize here, just a little techie thing, just to give you a sample of how this looks like. So this is example code in Python. It's not complete at all. It's just to show you more as an illustration than anything else. It's what kinds of functions you can call. So you create a remote control object to a certain endpoint, which is the address of the simulator. Then you have to authenticate. There's an authentication step that you have to authenticate using some account so that you can be permitted to create and change objects. And then you get a response with some capabilities. And then what I have here is a little loop. I actually took this directly from my application, which is getting the waypoints that were created by the OpenStreetMap editor, and for each waypoint, I update. Basically, I create an update item structure with a new location and the new rotation, and also what kind of asset it is. What asset should represent this waypoint? So that's sort of the object itself, and then I do create bulk objects. So this is in the beginning when I have when I connect and I already have a traffic model and I want to show it in world. So I just create all the objects in world. And the other thing is that you can enhance these objects with the possibility of calling back. So that's the register updated callback, saying for all of these objects, if something changes, please call me back, my script. And this script can be running anywhere. In fact, in my setup, my development setup, I have the script running here on my development machine at home, and I'm controlling an open simulator that is running in a server somewhere in Germany. So that's how it is, and I really encourage people to try this on. Let me tell you, this requires some expertise in coding, in understanding how these things are put together. You have to know how to write Python. You have to understand how to work with region modules and install them and things like that. So this is not sort of a drag and drop kind of interface. This is a very programmatic and techy interface, but I highly recommend it. It's really, really cool. And it really completely opens up these virtual spaces to very dynamic content in a very simple way. You can connect this script to all sorts of data sources and represent that data in world however you wish. So that's it. I'll be happy to take some questions now. Thank you.
Crista, thank you very much. I want to, will you be around later for people to talk to you if they have questions?
I am going to be around, yes.
Okay, great. I want to remind the audience that you can see what's coming up on the conference schedule at conference.opensimulator.org. And the next session will be Without Delay, Jazz Up Your Teaching with Virtual World Learning. And we encourage you to visit OSCC16 Poster Expo in the OSCC Expo 3 region and find accompanying info on presentations, and explore the Hypergrid Tour resources in OSCC Expo 2 region. So we will be right back with our next session at 8 a.m. Thank you.